Good morning, everyone. Thank you for joining my session. Today, we're going to talk about the story that we're making at Usabilla. It's a story about essentially how we're organizing or reorganizing our architecture. But before jumping straight to that, I have to share with you that a couple of weeks ago, I was in Italy. And it was amazing, all the food, the company. But one of the cities that I visited was Bassano del Grappa. And in that city, I found a bridge. This bridge. This bridge is like when you translate to English, is the Alpini Bridge or the Old Bridge. And it was built a long, long time ago. Around 1569, it was redesigned to match with these specs that you can see here. And throughout the time, even though after the redesign, it was destroyed completely and rebuilt. The last time it got destroyed was the Second World War. And there were many fights and battles here. If you go there, you will see the bullet holes in the walls, and it's really amazing to see the history there. And nowadays, you can see that there is some construction work happening there. You can see even all the stuff that is holding the bridge together. And together with my friends, we had like this moment when we find the perfect analogy. And we saw that this is one of the best ways to represent a life software. It has history. Many good and bad things have happened in this bridge. It has a utility. People are using to cross it. And it's actually being used, even though people are working on this bridge. And you can see there, we are there, right? And this is the definition of a live application we're going to use today. My name is Luis Cobucci. I'm a Brazilian, but I live here in the Netherlands for about 2.5 years. Now I'm working at Usabilla, and we have the mission to be the voice of the customer, which is what our end goal entails is to help them and support them to change and to improve based on feedback that they collect about their services. And when I joined the company 1.5 years ago, I found a pretty common situation, and I'm sure that you all can relate to this thing. It was a bit chaotic. I couldn't say that we had no tests, but we barely had tests. And the tests that we had back then were not covering the important parts of the application. We were using an outdated stack, outdated version of PHP, database, framework, libraries. Everything was so complex because of some decisions that were made on the past. People created some over-engineered solutions in order to solve a problem. And as you can imagine, as a development team, we were quite slow. I think we were releasing, and we kind of still follow this process, every 3 weeks. And for software, this is a bit too much. And obviously, we had bugs. If you modified some sort of structure here, you'll break something out there. And yeah, the servers were on fire, people were screaming. Rafael was saying that he was listening to some voices that it was like, you all gonna die or something like that. No, this is an exaggeration. But there was light. Usabilla has amazing people there. And back then, when I joined, they were already solving and tackling these problems by changing the culture, by getting people together and allow them to think and not only to work as a monkey. And we together, we said, let's refactor the shit out of it. And one of these, the stories that we had this is related to this saved search feature. The saved search is, we don't need to get into details about the feature itself, but it was a monster. And we used many weeks to refactor that. And by refactoring, and we're talking about the refactoring the whole thing, we were creating tests, ensuring that things are not breaking. And at a certain point of the saved search refactoring, we essentially we didn't see everything in the perfect solution or in a perfect condition. And the outcome of it was this. We sent about 50,000 emails to all the clients that were using the saved search feature. And this was caused because of complexity and things that were not in the right place being executed. So this was about when we should start sending emails about a saved search. And the starting point was being deleted from the database, from another parts of the system. And this was the old behavior, and the system was ready to do that. But the calculation of the next starting date was being overridden after you calculated once, and we just refactor based on the knowledge that we had before. And this what happened. And if you're a Usabilla customer, I'm sorry. I was personally involved with this, and to be honest, it felt worse than running a delete without a where. Yeah, it wasn't good. Although we managed to increase the quality. Now the project that we have there just moved from 3% of code coverage back then to 25%, which is quite an accomplishment. But remember about this, we actually don't have a single Italian breach. We have 6 of them within a single branch. And then you think like, how did we get to this place? And as any company, we have history, and some time ago we basically grew or evolved different parts of the projects using the very old technique of copy and paste. So we created a product, gave it a name for it, and then we decided to go to another kind of product. So we were collecting feedback from websites. Let's now collect from email. So we copied the product and then changed a bit. But the website was evolving as well. We were adding features here. And also on the email. And we have 6 different channels of feedback collection. And each one evolved separately. So you can imagine that we were in this kind of situation. Everything interconnected. We were dancing and lying in the mud. And there was a time that we said, okay, we need to do something about that. We need to unify these different channels. But without doing a major rewrite. Because we know about the risks that are involved with the major rewrite. We probably will spend a long time creating this perfect application that during the creation will probably be rushed, and then the bad decisions that we made previously won't be made, but we will create new bad decisions. And eventually this new software will be released. So if you go to any kind of, if you do research around this kind of problem, everyone goes to this pattern where you, I don't know if you know the background of it, but it was the name of Strangler pattern, or you create a Strangler application, was given based on these vines that grows around the tree, and they start right on the top of the tree, and they grow till it gets to the root, and it drains all the life in the tree while it grows. And eventually, you get to this situation where the tree itself dies because it doesn't have more life. But since the vine got its roots deeply in the ground, you have something that lives there. And the pattern goes basically like this. You have your big and scary application. And the first thing you do is to put a proxy around that, or in the middle of that. This won't do anything. This will just sit there and pass all the traffic to your scary and big application. Then you start to create something on the side of it. This is a nice and shiny thing. And this nice and shiny thing can be as small as a single endpoint. We don't care about that. Let's just put it there. Let's say that this application is an API and you're just extracting a resource. Then you make your proxy send the traffic to this new application. But you don't do this in a single way. You just say, oh, put 100% of your traffic there. We are engineers and we test things, right? We like to measure how things are evolving or not, and if they are producing the right results. So we pass, let's say, 10% of your traffic. You monitor it, and you see if you don't have any problems, if you're producing the right results, and the results that are being created there are able to be used in this the old system without crashing. Then once you tested that, you just pause the entire thing, and now instead of going to your previous application, this particular endpoint gets processed by this nice and shiny thing. If you want to do this over and over again, you can create things, do your tests, and test it, and ensure. And eventually, you will create more, do the same process, and there will be a point where this big and scary application won't be used anymore. Because, well, you have everything in different structure, in a better structure, so you don't need that. And it gets strangled, it dies. And you think, wow, this is amazing, let's just apply this everywhere, right? But hey, we have 6 Italian bridges. We can't do that because we don't have the same resource being processed for all the applications or the channels. We have one resource here, we have the other one here. So if we want to unify it, we cannot use exactly this pattern. So you feel depressed, but yeah, you think, okay, maybe we can do something different, but still trying to get some ideas from this pattern. And that's where this idea of decomposing applications starts to come. And that was our solution. So instead of just putting everything on a side and considering that you have this nice single resource, we're going to try to extract the behavior and understand how can we unify this thing in a nice way without breaking the application, but not necessarily already having all the traffic being sent to this new and nice and shiny thing. We're just going to get the data, store it in a unified way. But during this process, we didn't have much time. As any company, we had to rush. And how could we ensure that we won't make bad decisions during this process? And this quote is really good from Domain-Driven Design Distilled. If you haven't read it, please do it. And the nice thing is, there's no such thing as no design. You're always going to have a design. Whether it's good or bad is up to you. But you have to do something. And if we look at what we were dealing with, we already know the outcome of a bad design. So let's try to find not necessarily the best design ever, but an effective design. One that solves the problem and unify the issues. The starting point was gathering domain knowledge. But we couldn't do this by ourselves. We had help. And this is very important because when people start doing event storming, which was one of the techniques that we used, we usually have biased people facilitating this. So calling someone from outside is really important to help you drive the whole thing and focus on delivering business value and understanding your domain. If you don't know exactly how event storming works, just come after the talk and we can discuss a bit. We also did context mapping in a very naive way, though. But the idea here is to identify the elements of your bounded contexts and try to identify your core bounded context or your core domain and understand the relationship between each bounded context. So you can see on a context map what are the elements you have and how they communicate to each other. If you have anti-corruption layers around some bounded context, or if you decide to use different strategies to make different bounded contexts communicate. And doing this, we basically gather enough information to start writing Gherkin stories. If you haven't, I think we had a very good session about BDD and specification by examples yesterday. Go there and watch the talk, because this is really important to communicate about the behavior of your software. One thing that we also did was to measure everything. Rafael yesterday did this presentation. Go there and watch it. It's really good. But in the gist, what we did was define service level indications or indicators, which are things that we are going to track or things that are important to know about, and then we define some objectives around those. And in order to allow things to grow in a sustainable way, we decided to go to a service-oriented architecture or microservice architecture. I know there's a lot of things that you have to consider before deciding doing this movement, like how you're going to orchestrate your services, how you're going to ensure that your services are reliable and they are stable and healthy, and how you're going to deploy this without breaking different things, how these different things will work with a failure of another service. So you have to think a lot about that. We decided to work with autonomous services, and all the orchestration work is being handled by our ops team using Kubernetes now, and this was a very nice split, and we managed to collaborate. Now we're going to have our production cluster in a bit using Kubernetes. Another thing that this kind of architecture allows you to do is to think about evolvability of your software. And this is a concept that I was discussing with many different people back then. And then I discovered a book which is building evolvable architectures, and it's really amazing. But the gist is, imagine that you have 3 services, and regardless of how they communicate to each other, they have this communication. If you are to change the service A, you don't necessarily need to already remove the previous service. You can migrate things to the new protocol of the service A gradually, while you still have your service A running. And this allows things to evolve and being separately, and things will be consistent, because you don't need to necessarily change service B and C because of the change of the A. They can still rely on service A. But we want in the near future to remove service A. So then you just move the communication there, and eventually you're gonna say, okay, I don't have the old one because nobody was using. Usually this process can also be automated. So if you have a good infrastructure, you can measure the traffic that goes to service A and A line, and know when to remove the service A. And this is a really important thing. We decided to be very to simplify everything that we have. So at Usabilla, we for the API that we currently have and the app, which is our console, we use Symfony. Now still an outdated version. I think we're using 2.8, and we decided that we don't need all the great features that Symfony provides you, because Symfony is something that solves many different problems, but by solving this, it carries a lot of things. And even Symfony 4 with Flex, it still brings a lot of things to the table, and you probably don't need that. Our strategy was to use Zen Expressive with Tactician and dependency injection container from Symfony. So you can combine your components and get the best out of it. One of the things that I was doing before joining Usabilla was trying to work only on this component-based things, and this project was actually very successful and allowed us to just think about the core of our stuff. And my previous experience and all the stuff using Zen Expressive that I was doing back then helped us to create together Chimera PHP, which is a simple library that combines different libraries like Tactician, Zen Expressive, and Symfony dependency injection. But this is quite broad. We can evolve this a lot. But this is being quite helpful for us. We raised the strictness level of all the things, and this didn't make many people comfortable in the beginning. But we needed to ensure that everything was reliable and was not breaking. So PHP unit covering everything. We had PHP stand in a maximum level for everything we have, so source and some tests. Because we don't have an extension, a good extension to handle prophecy, we had to raise to make it to use level 4 instead of a level 7 in the tests. But eventually we can be able to contribute to the community as well and create or improve the extension for prophecy. We're using bhat, we're using infection, and to ensure that everything is consistent, we decided to use Doctrine code standard with some minor changes. That was also very strict and helpful for us. We needed to create an architecture that allows growth and scales well. And because we have services we have feedback collection throughout the whole world, and everything is processed in Europe. So in order to deal with this amount of load and requests and stuff, we had to think wisely here. And if we're talking about communication with different services and the style of the communication we did, we said that every service needs to be autonomous. So we have an event store which will receive events from all the services, and services can listen to it. And these can become easily your single point of failure, because if the thing that you have in the middle there fails, the whole thing, your whole system can crash, and this is not good. We decided to use Kafka in the middle because Kafka is really nice and it works really well with this kind of situation, because it is distributed and it's designed to be fault tolerant, and you can always create new brokers and add brokers to the cluster in order to scale and handle your load. Kafka works in a very simplistic way, we can say that. So you have topics. Each topic has partitions, and it works as an append-only log. So you cannot modify the history in Kafka. You just add data there. And the only way Kafka handles the order of the messages is within a single partition. Each partition of a topic is assigned to a broker. So this broker will be the leader of the partition, and all the followers will read and get messages from the leader to know what are the new things that have been read into this specific message. And if you, as I said, if you add a new broker there, it will load things automatically, and any consumer that you put and any producer will talk to the brokers properly. The producer will send messages to a broker in a specific partition, and you can pick, when you're writing to Kafka, you can pick, okay, I want to write to partition 1 or partition 2. And the consumer will also listen to things. One important concept is that you don't have only the consumer, you have a consumer group. And the consumer group is what defines what we are usually doing as consumers in different queue systems. So the consistency of the offsets, and to ensure that the message is only produced by one of the consumers within the group, is done in the group. So Kafka keeps track of all the groups that are running and knows which offset was the latest one that particular group is consuming. And one very interesting function of Kafka is the streaming API. And we're gonna show you a very simple thing here. Using the streams API in the whole thing that we created, if you go to this URL, you're gonna, let's hope that it works. But it will open our Usabilla feedback collection form, and you will be able to give feedback to this talk. Oh, sorry. Just a second. This. All good? So you can see that people are already sending feedback. And this is a nice thing that Kafka allows you. You can plug anything to a topic or to any consumer, any streamer, while the topic is there. So what I'm doing here is piping or listening to all the streams, all the messages that are coming through our stream, and I'm sending notifications to my file system here, my operational system. And this is done in a very simple way. It's important to say that I have no responsibility of what you're writing here. But this is essentially the code needed to create this streamer. And it's really simple. What I'm doing is creating a pipeline stream this pipeline will filter everything that is relevant to my application, or which is this particular form, this campaign. It will, for each message, I will write to my debug, my logger. I will show a notification, and I'm gonna store the information to a file. So I will be able to read every message that you sent to me. So I hope you were responsible while writing it. But it's really simple. The filtering is essentially this. You're managing objects. This is Java, but still. And the notification is just running an OSX command in the shell. Okay, kids, playtime is over. Yeah, if you try to send now, it won't catch because of the presentation. But how does it work with PHP? And the first thing that I saw was this. How about no? I mean, I'm very stubborn, and yeah. And the first thing that I saw was, okay, there's an extension here. Let's try to use it. The extension works very well to consume messages, but it doesn't work well to produce it, because it doesn't embrace the nature of PHP, which is your application is restarting over and over again. So when you're using PHP FPM, for example. And what happens with this particular extension at that time, probably they already fixed or they are trying to fix it, is that every new request that we received, it was creating a new connection in the C library. So when you have a huge amount of messages being sent, your endpoint gets very slow. So then we tried to find a PHP implementation based, also only PHP, handling sockets, and this is done using AMP. And although the design of the library is not good, it works well. So if you want to play around with Kafka, I suggest these two libraries, or one extension and one library. So let's get back to our story. We're talking about the starting point of this process, which is how we collect feedback. We designed an endpoint, or a structure, which was only responsible for receiving the data and piping it to Kafka. And because we decided to measure everything, we managed to get this information. And this information. So now we know exactly where the feedback is coming from, which channel, and how to understand it. And if we see a decrease on this dashboard, we see that something is not good. If we see that something is taking too important, this is the process. We're saying that it's response time, but this is actually done in PHP. So this is the processing time of the request. So I/O and that stuff is not considered here. So here, if we see that something is taking more than what we define as objective, we can already act upon it and change things. But our solution of being very minimum with our structure really worked. You can see that the response time is very slim. So what we did is get all the feedback and pipe from all the channels and pipe that to this new endpoint. So everything is duplicated. We have the old structure and the new structure receiving the very same data. And we are doing this and measuring as well. So really important. In terms of architecture, the processing thing works in this way. We write to a topic. We have a streaming process listening to that topic and doing some changes to the payload to ensure that everything is unified. We write the unified schema to a different topic, and then we process the information that we received by adding new data there. And that gets written to a different topic. So this is only the beginning of our journey. Like, we have still many things to add to this process. We have to unify different channels regarding form creation and the other things. But just by only doing this little bit of the feedback collection part, we learned some lessons which are kind of important to mention. Respect the constraints that you have and understand them. Although this is kind of stupid to mention, but it's like everyone should just know of it and should be able to understand the possibilities of each person that you have, the technology that you have. So respect this. Doing or getting everyone on board with this domain exploration to ensure that what we understand what's out there is really difficult. And we can not blame, but this is an important thing to mention. Conway law is something that we need to understand in order to promote the change. Because we still communicate we have communication issues in every single company, and we have to solve these issues. Otherwise, we're going to get to this situation. And I'm sure that nobody wants to be that. We have to be very disciplined regarding the decisions we're making. So let's not do let's not choose something and say that we're going to follow this and do something different during the process. Stick to your decisions or change them together and then apply things, but be disciplined regarding that. And that's our story. Unfinished story. Thank you very much. I think I went a bit too far regarding time. So if you have any question, please just come to me and I have 5? Okay, questions. The question was if I had any problem regarding processing messages more than once. We designed it to allow this to be resilient regarding that. So doing queues or just handling async messages, you probably get to that situation. Kafka has this configuration where you can do exactly once delivery, but that is a trade-off, and that makes Kafka a bit slower. So we created everything to, if we receive 2 messages, we're gonna handle them and ensure that we're not, if things are duplicated, we're just gonna reject some things and still be consistent. So we're safe on that area for that specific package part. More questions? So let me try to summarize. Your question is, how can we ensure that things are still consistent throughout time while maintaining 2 different sources or 2 different things that can evolve separately, right? And that's being a challenge for us. Now, this part is kind of easy because the feedback collection is stabilized. Stabilized? Yeah. We're not changing it. For that specific part is easy. We're now trying to apply and do the same thing for the configuration of your campaigns and triggers, and that's getting a bit more tricky because we still have to sync data, and for now the strategy is we're gonna simply sync and pipe the data to these 2 places. The old is still the single source of truth till we figure out how this is gonna be used in the interface. Once we have this, we're gonna start phasing out this. so that we only evolve the new interfaces we create. So thank you very much for being here, and I hope this was helpful.